Chapter 5, Lesson 7, Predicting with Linear Models. You can follow along in your book on page 316. Today we're going to determine whether a linear model is appropriate and use a linear model to make a real-life prediction. Two of your major goals in this course are to learn about different types of models and to learn which type of model to use in a specific real-life situation. In this lesson, you'll learn how to decide when a linear model can be used to represent real-life data. Example 1. Which data set is more linear? Remember that the word linear, we think about a straight line. So we're trying to see which one is in a straight line. The amount in millions of dollars spent on advertising in broadcast television and on the internet from 1995 to 2001 is given in the table. Which data are better modeled with a linear model? We have the years 1995, 1997, 1999, and 2001. Notice that your first row is your broadcast television. That's very thick. Your broadcast television. And your second is your internet advertising. A good way to decide whether data can be represented by a linear model is to draw a scatter plot of the data. Grab some graph paper and go ahead and graph the broadcast television as one scatter plot and the internet advertising as your second scatter plot. Press pause, and when you're ready to continue, press play. Here you can see the scatter plots. The first scatter plot is your television advertising, and the second scatter plot is your internet advertising. Yours should look very similar to mine. From the two scatter plots, you can see that broadcast television data fall almost exactly on a line. The internet data are much less linear. That is, the data points don't lie as close to a straight line. You try. The manager of a restaurant made the following table. Which data are better modeled by linear models? So here you are going to compare fish price and meat price for the years 1991, 1993, 1995, 1997, and 1999. You'll want to create two scatter plots, one for fish, one for meat, to answer the question. Grab some graph paper and graph each scatter plot. Press pause. When you're ready to continue, press play. You should have seen that your meat prices were more linear. If you were not able to get the correct answer for this example, go back and watch example 1. Example 2. Writing a linear model. Write a linear model for the amount spent on television advertising given the table in example 1. So we already have the actual table that we created. We're going to use that to make a scatter plot of the data and draw the line that best fit the points. The line does not need to pass through any of the data points. So go ahead and take your graph that you made in example 1 for television advertising, and we're going to use a ruler and draw a line of best fit for that graph. Do this now. Your line of best fit should look similar to mine. Again, the line does not need to pass through any of the data points, but you can see that it actually ends up passing through some of them, but not exactly all of them. To write our linear model, we need to find 2 points on the best fitting line. I chose to use the points 0, 32,720, and 6, 46,140. We're going to use the points to find the slope of the best fitting line. I went back one slide to show you where I got those points from. I chose the points 0, 32,720 because that's what our amount was in 1995. And then in 2001, which was 6 years after 1995, it was 46,140 million. All right, so using those points. Remember, when we're trying to find our line of best fit, we're trying to write an equation that's in slope-intercept form. Slope-intercept form is y equals mx plus b. So we need to determine what the m is and what the b is. M is your slope. So we're going to use our slope formula. y2 minus y1 over x2 minus x1. We're using the 2 points 0, 32,720, which will be our x1 and our y1, and the point 6, 46,140, which will be our x2 and our y2. Let's plug this in. 46,140 minus 32,720 over 6 minus 0. This is going to give us about 2,236.67. I'm going to round that to 2,237. This is what our slope is. When I look at my graph, I can see what the y-intercept is. The y-intercept is where your line is crossing the y-axis. That's at 0 years since 1995. So looking back at your table, you can see that in 1995, your line is at 32,720. So I'll substitute in my slope and the y-intercept. A linear model for the amount spent on television advertising is y equals 2,237x plus 32,720. You try. Write a linear model for the average meat price given in the previous you try problem. Press pause, and when you're ready to continue, press play. A sample answer would be y equals 0.13x plus 2.35. If you were not able to get the correct answer, go back and rewatch example 2. Interpolation and extrapolation. When you use a linear model to estimate data points that are not given, you are using linear interpolation or linear extrapolation. Linear interpolation is a method of estimating the coordinates of a point that lies between two given data points. Linear extrapolation is a method of estimating the coordinates of a point that lies to the right or left of all the given data points. Let's look at an example of this. Example 3. Use the linear model you found in example 2 to estimate the amount spent on, let's change that, the amount spent on advertising in broadcast television in the given year. Tell whether you use linear interpolation or linear extrapolation. So for A, we're going to determine with 1996, which is 1 year after 1995, and 2015, which is 20 years since 1995. Let's start off with 1996. We need to use the data for 1995 and 2001 to write the model. Because 1996 is between these two dates, we will use linear interpolation. Because x represents the number of years since 1995, you can estimate the amount spent in 1996 by substituting x equals 1 into the linear model from example 2. So we'll use the model that we came up with. We came up with the model y equals 2,237x plus 32,720. Since 1996 is 1 year after 1995, we're going to let x equal 1. Plug in your parentheses first, and then we can replace our x with 1. Now we can simplify. The model predicts that almost 35,000 million, or 35 billion, was spent in 1996. Now moving on to B, 2015. Because 2015 is to the right of all the given data, we will use linear extrapolation. You can estimate the amount spent in 2015 by substituting x equals 20, because 2015 is 20 years since 1995. So we'll use our model we came up with in example 2. Y equals 2,237x plus 32,720. Again, we're going to substitute 20 for x. And then simplify. 2,237 times 20. Take your answer and add 32,720, and you will get 77,460. Remember that our amount of dollars is in millions. So our model predicts that about 77,000 million, which is 77 billion, will be spent in 2015. You try. Use the linear model you found in the previous You Try problem to estimate the average price, not price per pound of meat in the given year. Tell whether you use linear interpolation or linear extrapolation. A, 2002. B, 1998. Press pause. When you're ready to continue, press play. If you were not able to get the correct answers for this You Try problem, go back and watch example 3 again. Need more help? Check out this video on YouTube.